So before I get started, allow me to ask you this question. So how many of you here are either AI users or AI builders? Thank you. And how many of you have so far volunteered either your skills or your time, anything actually at all? That's awesome. That's great. We're up to a good start. So, so today I'll be actually talking about AI for good projects, and I will be, I've actually picked two interesting projects. One where I volunteered my skills, right? Like it was already, the project was already available, but I will actually be expanding on the second part where we got together, as a complete strangers and worked on actual hackathon to, solve a problem. So the first one is about post-traumatic stress disorder. So the CEO of Color the World, called Christoph, reached out to Amdena and wanted us to build an AI-driven chatbot for PTSD assessment support. So what is PTSD, right? So PTSD is post-traumatic stress disorder, and it's actually kind of like fear that develops into a mental condition. So what is this exactly? Let's say, for example, so for Christoph, he and his team were in a war zone. Like, actually, they got ambushed in Central Africa. So they actually, they had something to do. And, they got ambushed. Something happened. Some of his teammates actually developed what we call PTSD. So it's like a fear, a normal fear that might actually, as you go through time, it develops into an exhilarating fear, like something that, makes you more anxious. Actually, you can't function normally. Like, let's say, for example, if you need to go out to work or something, you're fearful of something happening. So why should we build something like this? Obviously, there are lots of, psychiatrists and all of that out there. So the problem is that in war zones or actual zones where there are refugees, it's very difficult to find, doctors and especially specialists as one that would recognize what a PTSD is. And the problem with PTSD is that, if you have never heard of it, it's very difficult to know it's an actual mental disorder. So it shows up more like a fear. So what were the challenges in this project? So the problem we faced were, well, as is very typical in AI for good projects, where there is no money. So there was no data, no domain expertise. It was a broad problem statement. Yeah, we wanted a chatbot for PTSD assessment, and we were 32 AI enthusiasts, which is actually good and bad when you're, all over the place, like everyone is from different countries, international, global. Let's move on. So how did we solve these challenges, right? So the first one was that, well, apart from the fact that we were, global, everyone was in different time zones, it was very good that we were in different time zones. That means that we could do, different tasks at different times, right? When some of us are sleeping, other people are working. So what we did was we split tasks. So some people were interested to understand what PTSD is. Some other people were more interested in actually, trying to figure out how we could solve this using AI. And then some other people were more interested so where the heck are we going to get this data to train these models? So yeah, that's what we did. Everyone, roamed around, tried to figure out how we can solve these challenges. And then, yeah, we did it. We narrowed down the problem. So based on, obviously, all the solutions we came up with. And so especially the solutions we found were very broad. But obviously, they will much more of them would take more time. So what we did was that we took time as priority and the data we had. So, and we split ourselves into teams based on interests and expertise. What did we end up doing? Yeah. So we ended up, getting the data from our university. We use MLflow so we can, get the whole MLOps under control, from data ingestion to actual deployment of the model and then maintenance of it. And then we combined all of these tasks along with the NLP, creating a very simple NLP classifier to build the chatbot. So the solution for the programming language we use Python, and for training the model, so the framework is we use fast.ai, if you guys ever heard of it. And then obviously for the MLOps, we used MLflow, and then for conversational part, we used RASA-NLU, natural language understanding. So at first, usually it's like, the speakers today said, we need to do some benchmarking. And usually you might want to use some very simple models that you can test stuff with. So what I did, I tried, several classifiers, very simple ones. And as you can see, the accuracy was 75.20, 24%, which isn't really that promising. So yeah, we ended up scratching those. And one of us was actually investigating the latest model, which was ULM-Fit. So the transformer model I actually mentioning in the upper above is BERT. And although it did give around 80%, we weren't, when we gave it some edge cases, it wasn't really performing that well. So we tried this new model. So the difference between BERT, obviously, is a transformer-based model, and this one is actually, as you can see, it has LSTM components. And we ended up, deploying the model using MLflow and RASA-NLU. One thing, please, we didn't develop any fancy UI. So at the time, there was no Streamlit, no Gradu. So what we did was that, very simple command line. You kind of chat, the usual ways, like you're writing in the terminal. You communicate with the RASA-NLU for the conversation part, and then obviously the MLflow for the machine learning training and getting an answer. So by the way, the prediction at the time was, do you have PTSD or not? It's a binary prediction. And what we did was that after giving you this answer, we actually provided you guidelines on how you can, navigate around PTSD. So for example, if you had it, obviously. If you didn't, we still had warning risk, do you really have it? Might you have it? Please go check, with the doctor. If there is a higher chance, we obviously directly sent you to check with the doctor and some guidelines. Let's talk about the projects where we pop up, randomly, 8 ladies got together and worked on something. So the thing is, we were a bunch of ladies hanging out together from the Indiana bunch. And we were all interested in healthcare, and we wanted to contribute in, using AI. So what we did was that we actually, figured out if there was anything hackathon challenge that we could, contribute to. And we found this one from Microsoft Strategic. So what do they want, from this hackathon challenge? So what they wanted was to develop AI for healthcare solutions that will be making it easier to collect, analyze, and visualize data. So why? Well, to make the right decision quickly, because that's one of the most important things in the medical field. Remember in COVID-19, where everyone was, rushing around to hospitals? You guys didn't know this, but the radiologists were crying in the corner because there was so many scans coming in. So that's what AI could actually help us with. The challenges are actually very similar, so yeah. No data, once again, no domain expertise. Well, there was me. I was, I'm still doing my PhD in AI applied to healthcare, but obviously I'm not a healthcare expert. And no specific problem to solve this time. We don't know what the problem we're going to solve is. We obviously can brainstorm and come up with several ideas, but we don't have a specific one yet. We were 8 AI women enthusiasts. So second problem, we were global, we were international, so several time zones. How did they solve this once again? So we interacted with several months. So the really good thing about the hackathon I'm talking about is that they had several doctors, mentors, and they had the tech mentors, right? So we had diversity. So what we did, we already know the tech side. So what we did was, we kind of booked all the doctors out there and talked with them. One of them told us, so yeah, I know, AI is useful and all of that. We have a bunch of them in our hospital. So now how do we, can you please help us take the best, out of these AI models by helping us generate reports? Like, for example, the model did the prediction. We want to receive that prediction so we can analyze it and actually work with it. And so that's how we landed on our jackpot, the solution we needed to build. So what we did was like we got together, brainstormed different ways we could, build this solution for them. And we defined a solution workflow, then designed future perspective, because obviously you can't do everything in a month. So we developed the AI to detect hand. So one of the things that obviously we had to do was like take, an example so we could build an application, right? And so the doctor provided us with a couple of data images, DICOM format, to detect hand fracture. So this is like the toy model we were going to build. So we developed the code to generate the dashboard and report from AI because, we figured out if you want to know, what's happening in the hand fracture, you might want to know how many women have had this hand fracture, like what's their age, etc., if you want to do further analysis. Then we deployed the solution and designed UI UX for future perspective. Very similar. We used Python, but very different. We used Monai this time, which is a great medical library. Medical library to build the model. Then we used Fast API to communicate between the model and the front end, which was built using Streamlit, very easy to build UI with. So as I said, we were provided DICOM files. So the DICOMs usually have demographics and a couple of information around what the scanner used to scan the hands, for example, here. So we extracted the images from it, we pre-processed them, transformed them into JPEG, and then we actually got all the relevant information like age, all the actual anonymized information we might need. Like, for example, how many scans have been done. Then we feed them to the model, which is actually a DenseNet 121. Very simple, nothing complicated. And then we detected either someone had fracture or didn't through the image. So this is the workflow. You have the image. It goes through the model. The model tells you if that person has fracture or not. We extract information, as I said, from the DICOM, like what is your age, what gender you are, what type of scan was done to you. And then there was something else called severity that was actually added. And we generated the report, which has the personal information along with the prediction. And one of the things that the doctor wanted us to do was to provide them, with, hello, a report has been generated. The model has been fed something, and here's the result. And that's why you see here push notification, but obviously we weren't really able to implement it based on the time. So we deployed everything, the dashboard, the report generation. And as I said, we had 1 month, couldn't build everything. So what we did, we developed, what could be built if they gave us more time. So what did I learn from, well, actually, I think so far I have done 6 to 7 AI for good projects, and I'm very biased towards healthcare. So the model is as good as the data it is trained on. I believe you have already heard this. Garbage in, garbage out. So for example, if you give your model only data, let's say, for example, from Portugal, it's only going to recognize cases in Portugal, and you might actually miss some of the edgy cases that Portugal people might actually face. So please be careful that the data has to reflect reality, and when you're training on healthcare, be very specific around what you're doing. Data annotation can be a game changer if done right. So I was in a part of a project where, well, actually, most of the projects I was part of, we needed to annotate data. So one of the things we actually, landed on was that, let's say, for example, I might say this person has hand fracture, right? And then I might say, another colleague of mine might say no, right? So we might have different opinions, right? Let's say, for example, this actually happens a lot. So what we did was that in one project, we actually set a guideline, so here is what means fracture. Here are the things how to recognize it. And for edgy cases, we even had edgy cases. If it looks like this, please label like this. To make it easier for the model to learn. Why? Because as good as the data it is trained on, the model is going to be good or bad. So nothing is impossible. yeah, we can do everything, especially when you have a bunch of enthusiasts gathered together, ready to learn, ready to do things. We can build anything. But the problem is that we don't have time and we don't have the resources. Most of the time when you're doing AI for good projects, you don't have funding. So yeah. For a good collaboration, communicate frequently. Why? Let's say, for example, we all gathered together in this room, we're solving, I don't know, climate change problems. I am solving, for example, I am using, let's say, an object detection model. Someone is using, like, for example, a random forest, but we have no idea what's happening. How are we solving this, and what are we solving exactly, and what are, the challenges you're facing? Perhaps I have some answers to the problems you're facing, right? So for good collaboration, try to have as many meetings as you can, so you can figure out what is happening in your team. And now it's your turn. If you haven't done so yet, I invite you to volunteer. So for Amdena, for example, what they do is that they have a couple of challenges in different areas. SDG goals, they cover most of them. So you can just collect one, apply, and then they will be going you can go through a very, very simple interview, and they have a lot of different roles: machine learning engineer, product manager, you name it. So choose what you want, apply, and they will contact you. And if you're interested to join a bunch of crazy ladies gathered together, talk about life, and then do some AI for good, you're welcome to as well. And finally, let us empower individuals without a voice. Let technology be the salvation, because it is honestly the last barrier that we can cross and use leverage to solve almost any and all of our problems. Thank you. Feel free to reach out.
So thank you, Sara. We now have some questions from the audience. So the first question is from Catarina Farinha, which was in regards to the first project. And Catarina says that developing chatbots that help people with PTSD seems one of the most hard domains. And aren't you worried that the model can hallucinate and provide text that actually does the opposite? Or did you build predefined answers that are triggered when a certain route is hit by the user?
Yes. So at the time, there was no generative AI. This was in 2019. We were still, getting into this generative thing, but it wasn't a cool thing yet. So there was no such thing as, generating text. So it was very simple. It's, you had conversation. You either labeled them at PTSD, no PTSD. If there is a higher risk PTSD, then we just, suggested some kind of resources you can check out. And obviously, we always told the person to go check with a doctor, because this isn't this is not an expert.
Okay, thank you.
You're welcome.
We have another question from Diogo Santos regarding the maintenance of AI for good and volunteer projects. And this is a challenge we also have at the SSGPT. When we finish the projects, it's really hard for people to maintain and to be active because we don't pay them. How do you see this working for AI for good projects?
Yeah, so in this case, so the first one, it was we were part of Amdena. So Amdena, what they do is that they kind of find that NGO, so someone who cares deeply about the issue and will actually leverage the solution we're providing them and use it to solve the problem. So this is the easiest one. But if you're going in, if you want to get together with a couple of people and want to build something, make sure that you're building something you really care about, especially if you want to make it a startup, which is really super cool.
Mm-hmm. Okay. And a follow-up question by Ricardo Chaves. What is the average lifetime of these projects? Do you typically develop proof of concepts and sadly they are put into shelves and drawers and people don't use them? Or do you find real adoption of the people you try to help?
So for the Amdena part, they were used. For for us together, a couple of crazy ladies getting together to build something, yeah, we kind of put them on the shelf. We open source them so that if anyone wants to use them. But yeah, I mean, we actually do it just for fun. We don't do it to build, products for something.
Mm-hmm. Thank you. Another question from Maria Bader. Besides hackathons and the platforms you already spoke about, do you have any other spaces that you recommend people use to find a community to have to contribute to this project?
Yeah, so For myself, what I do usually, I just like search, like volunteer AI projects and something like that. So the ones I have already done myself, I have gone through Omdena challenges, Food Punch AI, if you ever heard of them. They have some really great, awesome, challenges as well. And well, apart from that, there is also like STEM Away, but it's more like educational. Like you do an internship, they teach you, project management and how to build models. And obviously, like it's just for learning. It's not really for impact. Mm-hmm. But if you want to do something for impact, please reach out to AI for Good NGO. It's a huge NGO that is like has a lot of startups involved in their system. Mm-hmm.
Thank you.
And they have obviously funded money.
Cool. I'm a bit biased, but you also have data science for social good Portugal.
Oh, yes.
I know there's a guy here that's from there. Okay, another question from Catarina. Do you typically follow up with the projects to check their impact? If so, how do you know if it's being impactful? And do you previously determine what are going to be the KPIs that you measure?
So usually, like with Omdena, for example, we do not check these kind of things because like most of the time we get together to learn something specific or, to kind of scale up. But they do, they actually like have their own KPIs. So it's like you're working on a real project. So everything is checked. You have project manager, you have product manager, you have the builders. So there's like a structure and they do follow up, but we don't. Like we usually only join to help use our skills and then scale up.